with a given focus and Directrix. This is a video 3. But now we have the curve of the parabola is in different position, and we are trying to answer this question. Let's go here. As we said from previous video, this distance of the directrix is this distance from the curve to the directrix d1 and from the curve of the parabola to the focus here is d2. Those two distances are equal with each other. We already know from previous videos, so I'm not going here to discuss any further. And now what we have here, the distance formula. Now we have to find this distance from this point, from the directrix to the curve to the parabola. We are going to find with the distance formula d1, which is equal with the square root of x minus x1 square plus y minus y1 square. So here let's find this formula here. X minus is in the formula, and this minus here become plus. We have here x plus p square. And now I'm going to look for the y coordinate. Y coordinate is a y, minus y is a plus, y minus y. So this is easy. I don't think it takes we have just to apply the formula for the distance, and d2 is equal with square root of, I have the same like I had in this part here, but different values. Here I have x minus p, so here is x minus p square, x minus p, everything here is in square, and the y coordinate is a plus, is a y minus 0, and everything here is square. And now if I'm squaring everything d1 and d2, then d1 square is going to be equal with d2 square. d1 square is going to be equal with d2 square. And now what I'm going to do here, if I'm squaring distance 1 and distance 2, what's going to happen is going to remain just the radicand, and the radical is going to disappear. And the same thing for d2 square. If I'm squaring everything here in d2, is going to be a d2 square, then what means the radical is going to disappear, and what is remaining inside the radical is just a radicand, and those radicand are equal with each other radicands. And now I can write here the d1, the radicand of d1 is equal with the x plus p square, and this is square, plus y minus y is a 0, and here I don't have an x plus p square plus 0 is just a x plus p square, so here I'm taking this shortcut. And in the other side I have a x minus p square, so d2 is a x minus p square, x minus p square. Here I have x minus p square, and y minus 0 is just apply plus y square, because y minus 0 is y, and because it's the square is y square. And now I'm just expanding those binomials, and if I'm expanding the binomials, it's going to be x square plus 2px, and plus p square, On the right side is going to be x square minus 2px, x square minus 2px plus p square, plus y square. So the y square is here, and this y square we should not forget to write down, otherwise we have a trouble. And everything here I'm going to subtract by x squared and p squared. If we are subtracting everything, we're gonna get as follows. Now let me take a different color here. Minus x squared both sides. Minus p squared here. And same thing I'm going here. Minus x squared here. Minus p squared here. And now I'm just cancelling everything, whatever I have, the same terms with different sign. I cancel here, we cancel here. Here we have to cancel. And here we have to cancel, and here. And now we are moving on. What remains here remains just 2px in this side. So 2px. Just this 2px remains here. What remains here? Minus 2px and y squared. So in the other side remains minus 2px. Minus 2px plus y squared. And I want x's and y's to put in two different places. So here I'm going to add everything with plus 2px. So let's add both sides 2px. And what we have here, 2px. I'm adding here. And I'm adding here 2px. What's going to happen here? Those are going to cancel because they have the same terms with different signs. And here I'm adding because 2px plus 2px is 4px. So here is 4px, but here is 4px. And this is equal, so I'm just switching the sides. And in this side remains just a y square, and this is a final formula for the parabola, or the graph of the parabola event is given in this Cartesian system with this given.